In this video 3-8, we will be looking at rotations. By the end of the video and work time in class, you should be able to say, I can rotate on a coordinate plane. A rotation is another type of transformation. We know a transformation, we're changing an image. We've talked about translation is sliding an image, reflection is flipping an image, and now into rotation is a type of transformation that will turn a figure. When we turn a figure, we have a center of rotation. That's the fixed point where the figure is turned. We can rotate clockwise or counterclockwise. Rotational symmetry is another rotation, is a specific type of rotation we're going to look at here, and I am going to take this image and show you when I rotate it one circle going, I'm going to turn it 360 degrees clockwise. We're going to look at how many times it appears just like this in that one turn. So we've got 1, 2, 3, 4, 5, 6. So it looked just like this 6 times in that one turn. That is what rotational symmetry is. When a figure matches its original figure when rotated 360 degrees or less. The angle of rotation is the number of degrees a figure rotates. So when we are looking at rotational symmetry and that angle of rotation, what we'll do here is we're going to find the angle of rotation of two images. What you do is you start with putting a point in the center of the image, draw a line going straight up to the top. Draw lines going to similar locations on the figure. So we're going to find other points that are like this. So we've got another one here. Another one here, here, another line would go here, and then we've got another line here. So you can see we have a total of 6 lines going out to the same location on this image. So what happens then is we have a total of 6 angles on the inside. So to figure out the angle of rotation, how many degrees can we turn this clockwise and so that it looks this exact same way? So how many degrees is it going to take to turn this going clockwise so that the image appears the same way it does right now? You take a full circle, which is 360 degrees, you divide it by how many angles there are inside after you draw the lines, and we count the number of angles inside. We see 6, so once we divide by 6, we get 60 degrees. That would be the angle of rotation. So if we took the hexagon, just like I did here a little bit ago in the previous slide, if I took the hexagon, rotated it 60 degrees clockwise, it would look just the way it does right now. Same as if we did 60 degrees counterclockwise. If you take a star and you put a point in the center of that star, draw a line going to the point and all the other points that look just like that, we see that we have a total of 5 lines. So for the angle of rotation, we also see here that there's 5 angles, and those angles are congruent. If we take 360 degrees, divide it by 5, we get 72 degrees. So if we were to turn that star 72 degrees clockwise or counterclockwise, it would appear this exact same way. And that is what rotational symmetry is. We are going to take a graph, a coordinate plane. We're going to graph a rectangle A, B, C, D. We're going to locate A at 3, 2, B at -3, 2, C at -3, -2, D at 3, -2. So here's our rectangle A, B, C, D, close it back up. We are going to take this rectangle, we are going to turn it around the fixed point of the origin. So we're turning it around the origin. We're going to turn it counterclockwise 90 degrees. So that means we're going to turn this direction 90 degrees. Now to do this, we'll start with our A. Our A right now is at 3, 2. So if this is at 3, 2, we're basically flipping it 3, 2 to 2 and 3, flipping your numbers around, but we want it to be in the second quadrant. So to be in the second quadrant, we would have to go negative 2, 3. So what I did is I took what the coordinates were to get here, 3, 2, flipped them around 2, 3, but to get in the second quadrant it has to be negative 2, 3. It's kind of a little bit confusing, but what you can see here is from the first where A was and now where the A is at A prime, if you were to draw a line going from the origin to the A to the next A, you see a right angle. That means we turned it 90 degrees. So now what we'll do is we'll take B. The B right here is at negative 3, 2. So we want to flip those numbers around. So it's negative 3, 2, flip them around 2, 3. But to get into the third quadrant, you have to go negative, negative. So it's negative 2, negative 3. This is where our B prime would be located. The C right here is at negative 3, negative 2. So flip the numbers around, negative 3, negative 2, flip it so that you have a 2 and a 3. And so now you want a positive 2 and a negative 3 to get in our fourth quadrant. Once again, we're turning it clockwise, or counterclockwise. So here's now where our C prime would be located. And then D is at 3, negative 2, flip them around, that'd be 2, 3, and it'd be positive, so we get up in the first quadrant after we rotate it counterclockwise. So there's D prime. So what you can see here, when we connect A prime to B prime to C prime to D prime and close it up, it's the same image, it's the same rectangle, same size, same shape, it's just rotated. So now you can see that rotation 90 degrees counterclockwise. Can you say I can rotate on a coordinate plane? I want you to graph the points T, U, and V to make a triangle, and after you do that I want you to rotate it counterclockwise 90 degrees about the origin. Name the new coordinates of the new image, and we'll go over that in class tomorrow.